Hello, class. Today we're going to learn about projectile motion. In our previous lessons, we have studied one-dimensional motions, including uniform linear motion, uniformly accelerated linear motion, and free fall. In today's lesson, we'll study two-dimensional motion with projectile motion as a typical example. It is the motion of an object in two-dimensional space only under the influence of gravity, just like the motion of a basketball. First of all, we need to understand an important rule that any two-dimensional motion can be considered a combination of two independent one-dimensional motions in two perpendicular directions, in which the time of motion in the two directions is the same. In the case of an object in projectile motion, we can resolve its motion into the horizontal motion on the x-axis and the vertical motion on the y-axis. The initial velocities of the object on the x and y axis are v naught cosine theta and v naught sine theta, respectively. On the x-axis, the acceleration of the object equals 0, which means the object is in uniform linear motion. So we have the equation of the position of the object as follows: x equal x0 plus v naught xt, and the velocity equation of the object is vx equals v naught x equal v naught cosine theta. On the y-axis, the acceleration of the object equals g, which is the gravitational acceleration, with up as positive, ay equals negative g. This means that the object is in uniform accelerated linear motion. So the equation of the position of the object is y equals y naught plus v naught yt minus 1/2 gt squared. And the velocity equation is vy equals v naught y minus gt. And also the relation between the position and the velocity of the object is vy squared minus v naught y squared equals minus 2g times y minus y naught. Okay, so here is the system of 5 equations. Now substitute t from equation 1 into equation 3. We have the trajectory equation of the object, with the assumption that the object starts at the origin, which means x naught equals 0 and y naught equals 0. So the trajectory equation of the object is y equals v naught tangent theta times x minus 1/2 g over v naught squared cosine theta squared times x squared. And this is an equation of an inverted parabola. Therefore, the trajectory of the projectile motion is an inverted parabola. Next, to find the maximum height h max that the object reaches on its trajectory, we use equation 5, assuming that at that point Vy equals 0 and y equals h max, which leads to h max equals v naught y squared over g. And finally, the horizontal range. To find the horizontal range that the object travels, first we use equation 3 with y being the height of the final distance, the final point. And we solve for t, which is the time of flight. And then we substitute t into equation 1, and we get the range of the object equals v naught x times t flight. And that is the end of the lesson. Thank you for your attention.